This is an audio-visual presentation on graph of relations. Now you look at the types of relations. We have the linear relations, we have the quadratic relations, we have the cubic relations, and the special relations. Now with the linear relations, any relation of the form y equals mx plus c, where m and c are constants, is called a linear relation. An example, we have y equals 2x plus 1, and we have 2y is equal to 4x minus 1. The graph of any linear relation is a straight line, and 2 points are enough to draw a straight line. Now let's look at how we can locate a point on the graph. That's locating point on the graph. Now this box is a 2 centimeters box. Is a 2 centimeters box on the graph. Now between the 2 centimeters box we have 10 small lines, 10 inner division lines. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have small inner division lines. Now, assuming we are given the scale of 2 centimeters to 2 units, that means that if we have 0 here, then we have 2 here. So the next one will be 4, 6 in that order. Now on the y-axis, here we also have 0, 2, 4 also in that order. Now, we know that there are 10 inner division lines. From 0 to 2, the distance will be 2. The distance will be 2 centimeters. So because we have 10 inner division lines, if you want to know the value of each line, what we do is to divide the distance by the number of inner division lines. So we divide the distance 2 by the lines, and that is 10, and this is equal to 0.2. So when we divide the 2 by 10, we have 0.2. That means that each small line is 0.2. So if you are starting from 0, when you add 0.2 to 0, you have 0.2. When you add 0.2 to 0.2, you have 0.4. Plus 0.2 give us 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, then you have 2. Also on the y, when we divide the distance, that is 2 by the number of lines, which is 10, the result is 0.2. That means the value for each small line is equal to 0.2. So starting from the origin 0, we have 0 plus 0.2, that is 0.2, plus 0.2, that is 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8. By the time we get to the 10th line, we have the number, and that is 2. Now, let's look at how we can locate this point 1.2, 1.8 on the graph. How do we locate this point? Now, first, you know that the distance, this is a 2 centimeters box, so we have the distance from here, from this end to the other end is 2. Now we know that there are 10 inner division lines. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we divide the distance 2 by the number of lines, and the result is 0.2. That means that the value for each inner division line is 0.2. Now with the point 1.2, 1.8. 1.2 is the x value, and 1.8 is the y value. Now with the 1.2, we know that on the x-axis, the value for each inner line is 0.2. If you are locating the point 1.2, we start from 1 because 1.2 is greater than 1. if you want to start from 0, we will still get to the same point, but it will take us time. So since 1.2 is greater than 1, we start from 1. But we know that each line has been calculated to be 0.2. So starting from 1, we have 1 plus 0.2, and that will give us 1.2. It means we are here, and that's the dotted line. Now on the y, we have 1.8. So we also start from 1, and we add the value of each line. So 1 plus 0.2 give us 1.2. Plus 0.2 give us 1.4. So 1.6, 1.8, and this is the line. Where the two lines meet, the horizontal and the vertical line meet, that is where we have the point. So this is the point 1.2, 1.8. Now let's look at how we can locate the point 1.3, 1.5. Here it is still 2 centimeters, is 2 units. So we divide 2 by the number, the internal lines. So we divide 2 by the number of the inner division lines is 10. So we divide the 2 by 10, and that will give us 0.2. Now we are locating the point 1.3, 1.5. And 1.3 is greater than 1, so we can choose to start from 1. Now 1 plus the first line 0.2 will give us 1.2. We are not up to the point yet, so we add again. Now 1.2 plus 0.2 is 1.4, which is greater than the x value, because the x value is 1.3. So take note, when we started from 1, when we add 0.2 to 1, we had 1.2. But when we added the 0.2 again, we had 1.4. That means that the 1.3 is between the 1.2 and the 1.4, and that's the dotted line you see. Now we consider the y-axis 1.5. So starting from 1, we have 1 plus 0.2, that is 1.2, plus 0.2, that is 1.4, plus 0.2, that is 1.6. So between the 1.4 and the 1.6, you have the 1.5. Now where the horizontal line and the vertical line meet, that is where you have your point. That is where you have your point. Now assuming the scale has changed, this is now 2 centimeters is to 1 unit. So we have 0, 1, that's on the x-axis. Then we have 0, 1 also on the y-axis. Now, if the distance is 1, we know that the inner lines is 10 between every 2 centimeters box. So because the distance is 1, in this case we divide 1 by 10, and the result is 0.1. That means that each line is 0.1. So if you have 0 here, plus 0.1 is 0.1, plus 0.1 is 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then you get to 1. And the same thing happens also on the y-axis. Now example, draw the graph of the relation y equals 2x plus 1 in the interval -2 is less than or equal to x less than or equal to 4. You are supposed to draw the graph of the relation y equals 2x plus 1 in the interval -2 is less or equal to x less or equal to 4. Now let's look at the solution. This is the relation that was given, and this is a linear relation. We have y equals 2x plus 1, and we are given the interval from -2 to 4 inclusive. So -2 to 4. So it means we have -2, -1, 0, 1, 2, 3, 4. That is the set. Now, when x is equal to -2, it means that wherever we see x in the relation y equals 2x plus 1, we substitute it by -2. So when x equals -2, y is equal to 2 times, instead of x, you have 2 times -2, because the x equals -2 plus 1. So y will be equal to 2 times -2 is -4 plus 1, and -4 plus 1 is -3. Now when x equals -1, By substitution, we have y equals 2 times minus 1 plus 1. And 2 times minus 1 is minus 2. Minus 2 plus 1 is minus 1. We continue. When x equals 0, it means that wherever you see x in the relation, you substitute it by 0. So we have y equals 2 times 0 plus 1. And 2 times 0 is 0. 0 plus 1 is equal to 1. So the value of y equals 1 when x is equal to 0. So now, when x equals 0, what is the y value? When x equals 1, what is the y value? When x equals 2, what is the y value? Up to when x equals 4. And I give this to you as an exercise to calculate the corresponding y values for 0, 1, 2, 3, 4 using the relation y equals 2x plus 1. Now, after calculating the corresponding values of these x values, this is the completed table you are going to have at the end. So when x equals 0, y will give us 1. That's when x equals 0, y will give us 1. When x is 1, y will give us 3. So when x is 1, y is 3. When x is 2, y will give us 5. When x is 3, y will give us 7. When x is 4, y will give us 9. This is the completed table for the relation y equals 2x plus 1 within the given interval. Now this is the graph. This is the graph. We have the y-axis, we have the x-axis. Now the first point is minus 2, minus 3. So we have minus 2 on the x-axis, we have minus 3 on the y-axis, and this is the point. Now we go back to the table. The next point is minus 1, minus 1. So you have minus 1 on the x, then you have minus 1 on the y. We go back to the table, we have 0, 1. So we have 0 on the x, then we have 1 on the y. Then we go to the table, we have 1, 3. So we have 1 on the x, then we have 3 on the y. We have 2, 5. So we have 2 on the x and 5 on the y. 3, 7. So we have 3 on the x and 7 on the y. We have 4, 9. So we have 4 on the x and 9 on the y. And we now draw a straight line passing through all the points. This is the line y equals 2x plus 4. Now we look at quadratic relations. Y equals ax squared plus bx plus c, where a, b, and c are constants. So quadratic relations are relations of the form y equals ax squared plus bx plus c, where a, b, and c are constants and a is not equal to 0. Why are we saying a is not equal to 0? It is because the constant coefficient of x squared is a. So if a is equal to 0, then it means that 0 times x squared will give us 0. And it is the exponent 2 that determines the quadratic nature of the relation. So the a should not be equal to 0. Example, if you have y equals 3x squared plus 5x minus 2. 3x squared plus 5x minus 2. Now when we compare these two equations, we realize that a equals 3. That is the coefficient of the x squared. The coefficient of the square term equals 3. Then b equals 5, where b is the coefficient of x. So the coefficient of x here is 5. And c is minus 2. C is the constant. C is the constant. And here the constant is minus 2. So c equals minus 2. Example, copy and complete the table of values below for the relation y equals x squared minus 2x minus 3 for minus 2 less or equal to x less or equal to 4. This is the interval and this is the relation. It's a quadratic relation. Now, this is the uncompleted table we are given. So the x values are -2, -1, 0, 1, 2, 3, 4. Now, using a scale of 2 centimeters to 1 unit on both axes, draw the graph of the relation. Draw the graph of the relation. Now, we look at the solution. This is the uncompleted table from the question. Now, the relation is y equals x squared minus 2x minus 3. So, when x equals -1, by substitution, we have y equals -1 squared minus 2 times -1 minus 3. -1 squared is 1. -2 times -1 is +2 minus 3. Now 1 plus 2 is 3. So 3 minus 3 is equal to 0. That means that the y value is 0 when x equals -1. Now when x equals 1, by substitution we have y equals 1 square minus 2 times 1 minus 3. 1 square is 1. -2 times 1 is -2. We have -3. So 1 minus 2 is -1 minus 3, and y is equal to -4. When x equals 2, we do our substitution and we have y equals 2 square minus 2 times 2 minus 3. And 2 square is 4 minus 2 times 2 is 4 minus 3. Now 4 minus 4 is 0. And 0 minus 3 is -3. So the value of y equals -3 when x is equal to 2. Now when x equals 4, y equals 4 square minus 2 times 4 minus 3. And 4 square is 16. -2 times 4 is -8. And we have -3. Now 16 minus 8 is 8. So 8 minus 3. And the answer is 5. Now this is the completed table. The completed table is as shown. We calculated the y value of -1 and we had 0. The y coordinate of 1 we had -4. And the y coordinate of 2 is -3. Now the y value of x equals 4 is 5. So this is the completed table. Now we go to the graph. The first point is -2, 5. That's the first point. Now the next point is -1, 0. So we have -1, 0. 0 minus 3. So we have 0 minus 3. 1 minus 4. We have 1 minus 4. We have 2 minus 3. So we have 2 minus 3. We have 3, 0. So we have 3, 0. We have 4, 5. So we have 4, 5. Now we draw a curve passing through this point. It's a freehand graph. It's a freehand graph as shown. It's a freehand graph as shown. Now let's look at interpretation of the graph. We have the least value or point. Now this is a minimum graph that has a least value. And the least value is the value of the y corresponding to the least point, corresponding to the least point. Now, from the minimum curve, the least value is -b. The least value is -b. But the least point is a minus b. That's with every point we have the x coordinate and we have the y coordinate. So if you look at this particular point, that is the least point. That's the least point. The least value will be -b, but the least point will be a minus b. Now this is a maximum curve. This is a maximum curve. So we have the greatest value, and the greatest value is the value corresponding to the highest point, corresponding to the turning point. So now the greatest value is equal to b. But with the greatest point, you need the x coordinate. So x coordinate is a and the y coordinate is b. So the greatest point is ab. But the greatest value is the value corresponding to the turning point on the y-axis. That's the point B. Now we have equation of the line of symmetry. The line of symmetry is a line that divides the curve into two equal halves. So this is the line of symmetry for this graph, and this is the minimum graph, and this is the maximum graph, and this is the line of symmetry. Now take note that the line of symmetry is passing through the point A on the x-axis. So if you want the equation of the line of symmetry, it is x equals that value, so x equals A. This is the maximum curve. Now this is the line of symmetry. That's the line dividing the curve into two equal halves. That line passes through A on the x-axis. So x equals A is the equation of the line of symmetry. Now let's look at how you can find values of x for which y is less than 0 or y is less than or equal to 0. Values of x for which y is less than 0. Now take note that the y is the curve. So if you are searching for values of x for which y is less than 0, that is the part of the curve below the x-axis. But take note, because it's y less than 0, take note of the inequality sign. This is less than. That means that A and B are not included. Now, for y less than or equal to 0, it's the same interval, but now the sign has changed. So it is A less than or equal to x, less than or equal to B. Now, values of x for which y is greater than 0 or y is greater than or equal to 0. Now, if you want to look for the values of x for which the curve or y is greater than 0, then these are values of x greater than b and less than a. So for y greater than 0, there are values of x less than a and values of x greater than b. Now for greater than or equal to 0, it means that the a and the b are all inclusive. So it's x less than or equal to a and x greater than or equal to b. Now values of x for which y is less than 0. This is a maximum graph. So the value of x for which y is less than 0 or y is less than or equal to 0. So when you consider this maximum curve, values of x for which this curve is less than 0 will be x less than a, x greater than b, because that part that's below the x-axis. Take note, because it's y less than 0, it means the a and the b is not included. But for y less than or equal to 0, it means we include the a and the b. So we have x less than or equal to a or x greater than or equal to b. That is x less than or equal to a, that is to the left, or x greater than or equal to b, that is to the right. Now values of x for which y is greater than 0 or y is greater than or equal to 0. So for this is the maximum graph. So values of x for which y is greater than 0 will be above the x-axis, and above the x-axis in this area. So it's interval between a and b. But because it's greater than 0, look at the signs. It's less than sign. So x is greater than a but less than b. X is greater than a but less than b. Now for y greater than or equal to 0, this means that the a and the b are all inclusive. So we have a less than or equal to x, less than or equal to b. Now let's look at the range of values of x for which y increases as x increases. Now, previously I told you that the curve is the same as the y. So when we say the range of values of x for which y increases, we mean for which the curve increases as x increases. Now, the range of values of x for which the curve increases or y increases. Now let's analyze the curve. This is a maximum curve. From A to B, the graph is increasing. And from the same A to B, we can see that there is an increase in the x value from the left to right. But from the highest point, the peak, that is B, coming down, we can see that the graph is decreasing. So if you want to find the range of values of x for which y or the curve is increasing as x increases, that means that it is from A to B. It is this portion that the graph is increasing as x is increasing. It is this portion that the graph or y is increasing as x is also increasing. But take note, at the turning point where there's a change from the increasing to decreasing, this is not included. So it is A, that's the starting point, less than or equal to x, but this is less than B because the B itself, that's the turning point, is not included. Now let's look at the range of values of x for which y decreases as x increases, where y is the curve. So if you want to find the range of values of x for which y decreases, it is this portion of the graph. It is from this portion of the graph where this point is the turning point. This point will be the turning point. So it means that B is also not included. Now here it means that the graph is decreasing. We can see that the graph is decreasing as the value of x increases. As we go to the right, the graph is decreasing. So you can see. Now this is the turning point or the maximum point. So what we do is the B is not included. So it is B less than x, but less than or equal to C because our end C is also included. Now the range of values of x for which y increases as x decreases. We are looking for the range of values of x for which y increases as x increases. Now the y is the same as the curve. So when you consider this curve, you can see that this corresponds to the point A, the turning point corresponds to the point B, and this end corresponds to the point C. Now from A to B, we can see that the curve is decreasing. The curve is decreasing as x is increasing. Now from B to C, you can see that the curve is increasing as x also increases. So we are searching for the range of values of x for which y increases. For which y increases, that means that from B upwards, we are increasing in y as x also increases. So it is B less than x, less than or equal to C. Now the range of values of x for which y decreases as x increases. When we look at the curve from A to B, we can see that the curve is decreasing. And this is our starting point, that is A. So we have A less than or equal to x, but less than B because the B itself is not included, it's the turning point. So it's A less than or equal to x, less than B. Now let's look at how best we can solve this problem. Use the graph of the relation y equals x squared minus 4x minus 21 to solve the equation x squared minus 4x minus 15 is equal to 0. Now this is the relation from the question. We have y equals x squared minus 4x minus 21. And this is the question we have to solve. We have x squared minus 4x minus 15 is equal to 0. So solving this on the graph means that when we compare the two, the relation and the question we are given to solve, the x squared is still the x squared. You have minus 4x here, you have minus 4x here. You have minus 21 here, you have minus 15 here. So you can see that minus 15 is not equal to minus 21. So we have to work this equation out to look like the original relation. What we do, we have to subtract 6 from the left hand side and we subtract 6 from the right hand side. Why are we doing that? Because already we have minus 15. So if you subtract 6 from it, then we have minus 21. Then it can be the same before we continue from there. So we have x squared minus 4x minus 15 minus the 6 is equal to 0. We also subtract from the right hand side. So we have x squared minus 4x minus 15 minus 6 equals minus 21. And this is equal to minus 6. So from the relation, we have y equals x squared minus 4x minus 21. And after solving the equation given to us, we had x squared minus 4x minus 21 equals minus 6. And this can be written as minus 6 on the left rather. Then we have x squared minus 4x minus 21 on the right. Now, when we compare the relation and the question that you were given to solve, which we manipulated, we can see that x squared is the same x squared here with the same coefficients. Minus 4x is the same minus 4x here. Minus 21 is also now equal to the minus 21 here. So when we compare, you realize that y is equal to minus 6. Y is equal to minus 6. So y is equal to minus 6. Now, given y equals minus 6, we quickly go to the graph and draw the horizontal line to pass through minus 6 on the y. Take note that where that line touches the curve, we trace it to the x-axis, and that will give us the values of x, for which y is equal to minus 6. Now, let's consider this question. Use the graph of the relation y equals x squared plus 4x plus 3 to solve the equation x squared plus 4x plus 3 equals x minus 2. Now, let's look at the relation given. You were given y equals x squared plus 4x plus 3. And now, arranging this, we can have x squared plus 4x plus 3 on the left hand side is equal to y on the right hand side, which is the same relation. Now, we were given x squared plus 4x plus 3 equals x minus 2 to solve. Equals x minus 2 to solve. Now, when we compare the left hand side, you can see that everything on the left hand side here is the same thing here. So we now equate y to x minus 2. So y is equal to x minus 2. This is a linear equation. This is a linear relation. Now, with y equals x minus 2, how do we draw the line? How do we draw the line? We select values of x and use the relation to calculate their corresponding values of y. So when x equals 0, it means that wherever you see x, you put 0. So we have 0 minus 2, and the answer is minus 2. That means that 0 minus 2 is 1 point. When x equals 2, y will be equal to 2 minus 2, and the answer is 0. That means that 2, 0 is also another point. So these are the 2 points we have. Now on the graph, we have 0 minus 2, and we have 2, 0. So we draw a line passing through the 2 points, and that's the straight line we are talking about. Now, where the straight line touches the curve, you trace them to the x-axis. That will give you the value a and b. That will give you the value a and b. Now, example. Copy and complete the following table for the relation y equals 3 plus 2x minus x squared. 4 minus 2 less than or equal to x less than or equal to 4. Now, this is the uncompleted table. This is the uncompleted table which we are going to fill with the help of the relation. Now, taking 2 centimeters to 1 unit on both axes, draw the graph of the relation for the given interval. Draw on the same axis the graph x minus y is equal to 0. Now, using your graphs, solve the equation 3 plus 2x minus x squared equals x. Find the values of x for which 3 plus 2x minus x squared is equal to 2. Now, solution. We are given the relation y equals 3 plus 2x minus x squared. So we need to find the corresponding values of y for the corresponding values of x. Now, when x equals minus 2, it means that wherever you see x in the relation y equals 3 plus 2x minus x squared, we substitute it by minus 2. So y equals 3 plus 2 times minus 2 minus 2 squared. And we have 3 minus 4 because 2 times minus 2 is minus 4. Then minus, take note that the minus 2 squared is 4. It's 4 times, so we have minus 1 times the 4, and that will give you the 4, minus 4. So we have 3 minus 1, 3 minus 4, that is minus 1. So we have minus 1 minus 4, and the answer is minus 5. Now when x equals 1, by substitution into y equals 3 plus 2x minus x squared, we have y equals 3 plus 2 times 1 minus 1 squared. And we have y equals 3 plus 2 minus 1. Now 3 plus 2 equals 5. And 5 minus 1 is equal to 4. Now when x equals 1.5, we have y is equal to 3 plus 2 times 1.5 minus 1.5 squared. And we have y equals 3 plus 2 times 1.5 is 3 minus 1.5 squared is 2.25. So y will be equal to 6 minus 2.25. That is 3 plus 3 minus 2.25. And 6 minus 2.25 is equal to 3.75. Now when x equals 2, y will be equal to 3 plus 2 times 2 minus 2 squared. And we have 3 plus 4 minus 4. 3 plus 4 is 7. And 7 minus 4, the answer is 3. Now when x equals 3, by substitution, we have y equals 3 plus 2 times 3 minus 3 squared. And that is 3 plus 6. That is 2 times 3 minus 3 squared is 9. 3 plus 6 is 9. So 9 minus 9, the answer is equal to 0. Now when x equals 3.5, by substitution, we have y equals 3 plus 2 times 3.5 minus 3.5 squared. And we have 3 plus 2 times 3.5 is 7 minus 3.5 squared is 12.25. So we have y is equal to 10 minus 12.25, and the answer is minus 2.75. Now this is the completed table. This is the completed table that we are going to use in coming out with a quadratic graph. Now these are the points from the table. We have minus 2 minus 5. So minus 2 minus 5, our first point. Minus 1 0 minus 1 0, second point. 0 3, so we have 0 3. 1 4, we have 1 4. And 1.5 3.75. 1.5 1.5, then you have 3.75. 1.5, then you have 3.75. Now 2 3, so 2 on the x, then you have 3 on the y. You have 2 3. And 2.5 1.75. 2.5 then 1.75. This is the point. 3 0, so you have 3 on the x, 0 on the y, so you have 3 0. 3.5 minus 2.75. 3.5, that's in between 3 and 4, you have 3.5. Then minus 2.75. Then we have 4 minus 5, so we have 4 minus 5. Then when you are done locating all the points on the graph, you now draw your graph. You now draw your graph. Now see, the graph of x minus y equals 0 is a straight line. So we need 3 points. And 2 points is even enough to give us a straight line. So for x minus y equals 0, x equals, when x equals minus 2, it means that wherever you see x, you substitute it by minus 2 so we can find the value of y. Now from x minus y equals 0, when you substitute x equals minus 2, we have minus 2 minus y equals 0. And this implies that y is equal to minus 2. So when you solve for y, you get minus 2. Now with the same x minus y equals 0, when x is equal to 1, then this becomes 1 minus y equals 0. This one, y will give us 1. So it means that when x is 1, y is 1. That's the second point. The first point, when x is minus 2, y is also minus 2. Now let's consider the third point and see. X minus y equals 0. When x equals 4, then we have 4 minus y equals 0. Therefore, making y the subject, you have y is equal to 4. So 4, 4 is also another point. So minus 2, we have our point here. 1, 1, we also have a point here. Then we have 4, 4. We now draw a straight line passing through these 3 points. We now draw a straight line passing through these 3 points. Now, we have to solve 3 plus 2x minus x squared equals x. But let's look at our relation. Y equals 3 plus 2x minus x squared. Now, arranging the relation to look like the question we have to solve, we have 3 plus 2x minus x squared is equal to y. Is equal to y. Now, when you compare the left-hand side, you can see that the left-hand side of this equation, 3 plus 2x minus x squared equals x, is the same as the left-hand side of 3 plus 2x minus x squared equals y. So because the left-hand sides are the same, we can equate the right-hand side. So we have y is equal to x. And if you have y equals x, then you can say that y minus x equals 0. Similarly, x minus y will also be equal to 0. So now, if y minus x equals 0 is the same as x minus y equals 0, then it means that we already have this line on the graph, so there's no need choosing x values and finding the corresponding values of y. So now, after drawing our straight line, solving for this means we look at the point of intersection. We look at the point of intersection of the curve and the line and trace it to the x-axis, and trace it to the x-axis, and trace it to the x-axis. And this, when we locate this on the graph, we have x equals minus 1.3 or 2.3. That is, we have x equals minus 1.3 or 2.3. Now, dii, we are given the equation 3 plus 2x minus x squared equals 2. We are asked to solve this equation. Now, we write down the relation from the question. We have y equals 3 plus 2x minus x squared. Now we arrange it to look like the question we have to solve. So 3 plus 2x minus x squared will now come to the left, and y will now move to the right. We can see that 3 plus 2x minus x squared is the same as 3 plus 2x minus x squared. And so we equate the right hand sides. We have y is equal to 2. And y is equal to 2. On the graph, you locate where we have 2 on the y-axis, then you draw a straight line. You draw a horizontal straight line passing through 2 on the y-axis. And you locate the point of contact. We locate the point of contact of the horizontal straight line drawn in the curve. And these are the values. That is minus 0.4, and we have 2.4. That is minus 0.4 or 2.4. Now, cubic relations. Any relation in which the highest power of x is 3 is a cubic relation. Example, y equals x cubed minus 5x. This is a cubic relation where the highest power of the x is 3. That makes this relation a cubic relation. Now, in general, if you have y equals ax cubed plus bx squared plus cx plus d, where a, b, c, and d are constant, and a is not equal to 0. Because if a becomes equal to 0, there is no cube term left, and therefore it is no more a cubic equation. So for y equals ax cubed plus bx squared plus cx plus d to be a cubic equation, a must not be equal to 0. Now, example, copy and complete the following table for the relation y equals x cubed minus 5x. Now, I give this to you as an exercise. The relation given is y equals x cubed minus 5x. The x values are there, so it is up to you to substitute in place of x, and we see the corresponding y values. So you can even pause, complete the table before you continue. Now, continuation of the question is using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 2 units on the y-axis. Draw the graph of the relation y equals x cubed minus 5x 4 minus 2.5 less than or equal to x less than or equal to 2.5. Then from the graph, obtain correct to two significant figures, the least value of y equals x cubed minus 5x in the given interval and the truth set of x cubed minus 5x equals 1. Now solution. Given y equals x cubed minus 5x, when x equals minus 1.5, how do you find the corresponding y? We do substitution. So we have y equals, wherever you see x here, you put minus 1.5. So we have y equals minus 1.5 cubed minus 5 times minus 1.5. And this will be y equals minus 1.5 cubed equals minus 3.375. Minus 5 times minus 1.5 is plus 7.5. And so minus 3.375 plus 7.5 will be equal to 4.125. And this is approximately equal to 4.1. Two significant figures. Now, given the same relation, y equals x cubed minus 5x, we are still on the substitution. So when x equals 0, then y will be equal to 0 cubed minus 5 times 0, and the answer is 0. When x equals 0.5, by substitution, we have y equals 0.5 cubed minus 5 times 0.5. And we have 0.125 minus 2.5. And the result is y equals minus 2.4. So it means that when x equals 0.5, y equals minus 2.4. When x equals 2, y will be equal to 2 cubed minus 5 times 2. And 2 cubed is 8. Minus 5 times 2 is 10. So 8 minus 10 is minus 2. That means that the value of y equals minus 2 when x equals 2. Now, given y equals x cubed minus 5x, the same relation, we are still on the substitution. So the next x value is 1. So when x equals 1, y will be equal to 1 cubed minus 5 times 1. And y will be equal to 1 minus 5. 1 minus 5 equals minus 4. This means that y is equal to minus 4 when x equals 1. Now, we still proceed. When x equals 2.5, y will be equal to 2.5 cubed minus 5 times 2.5. And when you simplify this, the result is 3.1. When you simplify, the result is 3.1. Now, the completed table is as shown below. So this is going to be the completed table. And I advise you to calculate the corresponding y values of the x values that were not given and see whether you get a completed table like this. Now, locating all the points on the graph, this is the nature of the points. So we join them by means of a curve, freehand as shown. And this is a cubic. This is a cubic curve from a cubic relation. Now, from the question, we have to find the minimum value. And the minimum value will be minus 4.2. Minus 4.2. Minus 4.2. That is the minimum value of this cubic curve. So the least value or the minimum value of x cubed minus 5x is minus 4.2 to two significant figures. Now B, we have to solve x cubed minus 5x equals 1. Don't forget the relation from the question is y equals x cubed minus 5x. So rearranging, we have x cubed minus 5x equals y. Now when we compare the left hand side of the two equations, x cubed minus 5x, x cubed minus 5x, you realize that the left hand sides are the same. So we equate the right hand side. So we have y equals 1. We have y equals 1. Then quickly we go to the graph. This is y equals 1. Then we look at the point of intersection of the horizontal line and the graph. We have this point, and that point. This point is minus 2.1. Here you have minus 0.2, and here you have 2.4. I advise you to do this in your graph and see if you are getting the values you are getting here. Now the truth set of the equation x cubed minus 5x is x is said that x is equal to minus 2.1, 0.2, and 2.4. This is the end of our presentation.